Okay, I've started the recording. Now, what the heck? Technical, oh, there we go. Okay, it's still recording, all of that. So, rules for differentiation. I need you, and you need to memorize right until day 120 or whatever when you write the AP test. The definition of a derivative, if you're asked, this isn't the full definition, but this is, you're asked to use the definition of a derivative to come up with a derivative. It's a limit. And keep this in mind at all times. I'm going to show you guys some shortcuts so you don't actually have to work this out every time. But you are actually doing a limit every time. And have this memorized. It's the limit of h approaching 0 for f of x plus h minus f of x all over h. It's the slope formula, right? With that limit, that h limit idea. And at any given time, can you describe a derivative? Not define, but what does a derivative give you? And I say, what does it give you? You would say, Miles, derivative is a formula that what?
Gives you the slope of it.
Gives you the slope of a tangent line. So you might come up with a derivative that says 3x squared. That means if you want the slope of the original function's tangent line at a given point, use 3x squared. Plug in 1 or x equals 2 or whatever. That's what you're finding. And I say it's an important section. You're going to learn these shortcuts instead of using that definition. But always keep in mind, you're actually doing a limit. You're not actively doing it though, but you still find it. So these limit rules, there's a reason why you got to keep it in mind. It'll come up every once in a while. So the first rule, you're going to be like, what? We could have done this all the time? Why did parse always have the answers right away? Here's why. If the function is equal to x to the n, like x squared, then the derivative is n, whatever the power was, bring it down, and then x to the n minus 1. It's actually a simple rule. It's not too bad. As long as n is a real number, and you'll also find that as long as n is a real number and it's not 0, it doesn't work either. Because it just zeroes everything out. So let's try this rule. Find the derivative of each of the following using that little method. And I'm going to use notation. If it's f of x, I'm going to say f prime of x for the derivative. If it's y, I'm going to use dy by dx for the derivative, okay? So I'll show you what the first one, f prime of x, is equal to. Never, ever do this. It's not equal. That's f of x, that's the function. This is the derivative, and you notate it. So it's not equal there. That's going to dissolve in a second. So according to that rule, whatever you have as the exponent, in this case 4, you bring it out in front and multiply it. So 4 times 10 is 40. X, 4 minus 1, x cubed. Can you imagine doing this one in the limit expression, f of x plus h, where you'd have 10, x plus h to the power of 4 minus f of x, 10x to the 4 all over h, limit of h approaching 0? So that, it would be a lot of work. You'd get the exact same answer in the end though. Now you see what I'm talking about, the shortcut? Okay. Try this one, and you're going to write down instead of dy by dx, just to get familiar with this notation. Different. Same rules, negative times a negative though, you know, those kind of things. And we'll see if we're hunky-dory. So I'm hoping you have this. Negative 3 times negative 7, right? So negative times a negative is positive, so 21. X to the? Good. Common error would be adding instead of subtracting, because I know you think it's 7 minus 1. No, it's negative 7 minus, so negative 8. Okay. This expression, I don't want to do it right away. Once you get familiar with this, you might. But we don't really have an exponent on this, but what does over x really mean if you were to make an exponent and bring it up to the top? X to the negative 1. Negative exponents are reciprocals. So before you do calculus, I suggest you just rearrange this. This is the same as x to the negative 1. Agreed? Because to put it back down, you'd make it positive. Okay. Once you have that, you can apply this rule, right? So dy by dx equals negative 11, x to the negative 2. Try that for d. A reminder, square root, the power is, the exponent is half. Try d and e and f, if you so desire. And g. We'll get to f and g there, but I think d, same method, rewrite it first. And then e, see what you can do. F and g. So. I'll just jot some things down while you're working. Track. Good. We good on this one? Okay, good. How about this one? There's a little, no calculus done yet, right? Just writing this as x to the half, because then we can apply our rule. So f prime, get used to the different notations. 4 times 1/2 is 2. Agreed? What's the exponent? Sorry? Oh, yeah, this has this glitch where I go from there and then I pick up the pen, thank you. So, negative 1/2. Great, you got that. If you were to evaluate that, though, using negative 1/2, how could you rewrite it with square root notation instead of exponents like halves?
Negative outside of the root or root on the bottom?
Yeah, because what does negative mean? Take the reciprocal, it becomes positive. Now, I wouldn't expect you to rewrite this, but that's what this means. And you know that that means 2 over the root of x. Because if you were going to evaluate something, you'd probably want to know that, right? Sure. Okay. This one here. 0. It's just 0, nothing. Like, it annihilates everything. So f prime of x is equal to 0. Why did I include that one? Because you'd never write down x to the 0. What does x to the 0 mean in the first place from the original expression? 1. So this is just the derivative of 3. So what if I said, if I just make up another one here, f of x is equal to negative 3 to the power of 4. What are you going to tell me f prime of x is? Is there any x? Is there any variable in this? Yeah, you could think it's 0. Like it's a constant, right? This is a number. Right? It's 81 actually. But even there's a temptation once you get into this multiply the exponent thing that somebody will bring down the 4, put it in front, and make that a power of 3. Don't do that. That's what I'm showing you there. It comes up. It's 0 though, right? Because this represents a number. What about this y expression here? Okay, dy by d. But we're going to use x as the most common variable because e in our calculus class and in math classes in university. What does that represent?
That number.
It's a number, 2.178. It's like pi. It's not a variable. So this is a number. It's a constant. I don't care what it is. All I need to know is the derivative is 0. Because if I graph this, this is the same value from left to right. It's a horizontal line if I graph y. So don't get tempted to say 14e. And that's usually first instinct, and that's why I'm showing these. Is 0. Okay? Another notation thing. What if I had, instead of dy by dx, just d by dx of this expression? It just means do the derivative. And I also, so this means do the derivative of this, and then this, and if it went on, you'd keep doing the derivative. So if you have adding or subtracting, you just do the derivative of each little chunk and add or subtract as necessary. So in this particular case, it already says the derivative of the expression. So you just jump right into it, and it's 2x. And what's the next one? Negative 2, x to the negative 3. Good. Subtracting with negatives, yeah. Making sure there. Now, what if I said evaluate f prime of 2, and I'm saying from a. So you're given this function 10x to the 4, right? F of. And I said find f prime of 2. What are you going to do? What do you suspect? You take your f prime expression, right? This. And our f prime expression is 40x cubed, right? So we're just going to take this. F prime of 2 is 42 cubed. So typically you would have an f of x equals, 10x to the 4. Evaluate f prime of 2. So your first thing is find the derivative, then plug into the derivative. 8 times 4. So 8 times 40 is 320, right? Now, what does this f prime of 2 represent? Keeping this in mind at all times, what's a description of the derivative evaluated at x equals 2 in this case? What?
The slope of the tangent line
At
x equals 2.
x equals 2. So if you graphed 10x to the 4, the original function, you went to x equals 2, it doesn't matter what the y value is, there's only one y value for it though, but it'll be really steep. Yeah, it'll have a steep slope of 320. That's how fast it's growing if the function represents a rocket ship speed or something like that, who knows? Okay, so this is the value of the slope at 2, that domain value. B, C, D, E, F from here. You can apply this rule to expressions that have addition and subtraction too. We've already talked about that real quickly. So, these ones, though, require some rearrangement. So B, I'm going to, before I even try doing calculus, I'm going to do some rearrangement. We already tried some like this, but there were one thing at a time. So before I do that, I go 3x to the negative 1. 5x to the negative 3. What's going to happen here? I should just pause for a second. This is why I included this one. I've stopped at this third item. How do I rewrite that one? don't be shy, give it a try.
5x to the negative 5 brackets.
Okay. It wouldn't be, because the 5 only applies to the x. Thank you for volunteering. Somebody found it.
Would you do it first at the bottom and then parallel down
X to the negative 5.
1/5.
But what about the, you could say 1/5, that wouldn't be incorrect. But well, it's a number. 7 out of 5 is a number. This is where people start flipping things when they shouldn't be. It's still 7 out of 5. Move this to the top, x to the negative 5. Then do your derivative. I didn't leave a lot of space here, so I guess I'll do it there. So I'm going to just change colors because it's going to run into things here. I'd really work underneath when if I planned that. Oh well. Hopefully you do this. Give it a second here. I'll compare with you guys. Mine's kind of cramped in there. But I wasn't talking, so I'm less likely to make a mistake. Am I right? Or am I wrong? That's what you got? BC Fruit Truck, Orchard, and then Randy Orchard got. Remember? That's what, apparently that's what your name originates out of. I read that. Family tree stuff. How about this one with the square on it? Do we have a rule when the exponent's on the whole bracket? We don't, to let you know. There will be one, but right now, if you get an expression inside a bracket, you got to multiply it out. So, I'm going to try this one out here. I'm going to maybe work in green for this one here. So that's equal to, I'll work it with you. 5x, 25x squared. I'm not doing calculus here today. So minus 15x a second time, 30x plus 9. Now, I can do some calculus. F prime of x. Now this part of it isn't hard, right? But you do have to be able to multiply out your binomials, trinomials, etc. And okay, I'm hoping you have this. 50x minus one answer. Let's hear one from that side of the room. 50x, good start. Then what? 30x to the 0. Would you write down x to the 0 though? You're right.
Minus 30.
Just say minus 30 then, right? Okay.
And then minus.
And then the 9 turns into a 0. So it's dropped. So, if you don't follow this one, you can imagine this is 30x to the 1, right? 1 times 30 is still 30, so minus 30. X to the 0. You would never write down x to the 0. Just, if you do, drop it the next step. Simplify. I don't want you having answers with x to the 0 in your final answer, right? You'll get used to this. And think of just, if you only had this as a function, negative 30x, that's a linear function, it's a line, right? What's the slope of that line if that's all there was? Minus 30, right? That's the derivative. So it should make sense from what we've seen before. Now for space reasons, I'm going to just skip D. But this you do the same thing. Multiply it out first. But you can see I'm getting cramped up. So I'm going to do E, a little bit of everything. What do you suggest we do before we do calculus?
Move the x
expand or multiply it out, and then distribute the division. You guys follow me on this? You can see why I'm going to run out of space if I try to. So E, I'll use red. So it's equal to, this is a difference of squares, so the center term will disappear. 9x squared, then minus 15x plus 15x, so zeros out, minus 25. Oliver, x to the 5th. Now, distribute your division in the sense, right? So it's x squared divided by x to the 5 using subtraction. 9x to the minus 3, negative 3. And minus 25, we're just playing around with this kind of thing at the other page here, x to the negative 5. So you see why first chapter I want you guys familiar with negative exponents and stuff like this? It comes up. Now I can do some calculus. So I'll continue on with E right underneath here. dy by dx. I'll let you guys tell me in a minute. I'll ask somebody. Well,
If we put y prime, would you don't?
I'm fine with y prime. Don't get used to seeing dy by dx. It's the most common thing in science-based courses. And I'd say it's about 50-50 in calculus. F prime of x, dy by dx. If you see y prime, no, that's fine. The norm is dy by dx, but y prime works just fine. Because I'd mentioned that too. So we've got our middle table. How about the right side? One of the three of you, Ryan or Sarah or Kayla. Go ahead. I don't care if it's wrong or right. Just give me an answer. Okay, and I couldn't hear x to the negative 4 though? Good. Okay. If you did that, you probably did this one right there. 125 x to the minus 6. Now, you can use calculators on your tests and stuff like this, but things like that, if you're slowing down to go 5 times 25, you should be able to do these in your head, right? Anyways, it's not illegal, but they're about 2/3 of the length of the AP test is without a calculator too. So really work on doing all of your arithmetic, if possible, as long as the numbers are reasonable. So this one here, we got to rewrite. Oh, f of x is equal to. How would I rewrite this one? Remember, separate the variable from the number. What is the number here, even though you don't have a 1 here? I like to think of it as 1x over 3, under the root sign. So what is the number? Okay, I can't hear. Someone's got an idea there, I hear. 1/3 with a root sign over top of it, though, right? Now, I'm going to write this down and then I'll let it disappear here. So he's saying, yeah, 1/3 is the number part. Can you do the square root of 1, though, quickly? Yeah. And if it was a 4, you'd do that too. Yeah. You can't do the 3, though. It's irrational. But let's call it 1 out of root 3 then, okay? To make it look as simple as possible. Do not rationalize your numerators. I've mentioned this before. Then, what is the x? Because we got a radical on it, what did we say to do when you got radicals on x's? Half. Yeah. X to the half. Do you see how that's the same part, that's the same expression? It looks like my x is grown into this. Everybody sees that so far is the same? Okay. The next one, people get messed up on that kind of thing. Just think numbers separate from the x. Minus 2, what would we call this one?
X to the negative.
Yeah, x to the negative half. We are still not doing calculus. This is just algebraic reassignment kind of thing. f prime of x coming up. I hope you can do this. I'll let you do it. Too. And don't worry about radicals on the bottom. They're fine. I'll stand in the way on purpose. And I want you to try. Don't worry about rewriting it with square root notation. Just keep it as negative fractions if you wish. If you ever have to evaluate, though, you should know how to get in there. I'll step aside now and you can see the answer. Is that what you guys are getting? Negative 3/2, negative 1/2 on the other. 1 over 2 root 3, x to the negative 3/2. Or negative 1/2 plus x to the negative 3/2. I hope you understand, though, what x to the negative 3/2 means. Do you? Who doesn't? Well, somebody probably doesn't, so I'm only going to do this in green because I wouldn't expect you to for this. But if you had to evaluate, I would suggest rewriting like this. 1 over 2 root 3. You could put root 3x, or if you want to put times x separately. I would actually put root 3 and then root x and put it here underneath the root sign. You probably noticed how I tend to make my square roots so that it's very clear what's included in it. Like that, right? And it ends there. Make sure your square root at least covers the whole expression that you wish it to cover. Plus 1 over, what's the best way to write that? There's two ways I could think of, and either way, if you were going to evaluate, what would you probably do first, the square root or the 3 part? Like if I said 8 to the negative 3/2, or not 8, I wouldn't do 8. If I said 16 to the negative 3/2, what would you probably do first? Square root first. Okay, so this, the out of 2 part means square root x, and then cube it. If you wish, you could put that x cubed inside there, but if you were actually evaluating, you'd get a huge number first. I would rather take 16 down to 4 and then cube it. That's the only reason why I do it this way. But either way is equivalent. X cubed under the root is the same. I've just given you a whole whack of stuff, but don't worry. We're practically done. So, is there any questions up to this point? I've got questions for you, so you'll find out. Find the coordinates of 2 points on this graph of the function x cubed, 3x squared, minus 3x, at which the slope of the tangent line is 6. It doesn't say anything about calculus, does it? Implicitly it does, but not explicitly. It doesn't say find the derivative or do anything. But as soon as I hear slope of the tangent line is 6, I think, what I need is a formula that gives me the slope of the tangent line at any x value. Then I could find those 2 x values. What gives us the slope of the tangent line at any derivative? So we do have to do the derivative. That's the lingo. Now, right now, it's probably a good guess because that's all we've studied in calculus. Later on, though, you'll have some other options. So, I'm going to keep plugging this in. So let's go with this. We need the derivative. He said so. Rashad knows his stuff, so I'm going to listen to him. Okay, got it. I got the derivative. Did I solve the problem? Heck no. This is the slope that gives you the slope of the tangent line. And it's not the slope formula like where it's y minus y over x minus x. This is for any given x value on the original curve. If I put in 1 or whatever here, it gives me the slope for x equals 1. We need to find 2 points, so we need to find 2 x values at least, and then y to follow up. Where the slope of the tangent line is 6. What do I do next?
6 equals.
The slope of the tangent line. So this, f prime of x, is the slope, really, right? So it's 6 equals. And this. Now, is that easy to solve in this form? What's the norm? Move everything over, right? And see if we can factor. Okay. So I'm going to drop the color thing. Just go with 0 equals 3x squared minus 9. We've got a factor now, but don't jump into the factoring with x's. Is there a common number, common factor? 3 makes your life a little easier. So 3 bracket x squared. Now, we're cooking with gas, as you can hope you can. Wait. Emily, you got it factored for me? No, you were just smiling and waiting. But Nisha does. What do we got? Good. Then, that has two solutions. And I want you to, I'm going to stop because I know you guys have been doing this for a couple of years, solving these quadratic equations. And you just automatically say x equals negative 3x equals 1 because you take the opposite sign to say. Why is it that x equals negative 3? Why is it that x equals 1?
X plus 3 equals 0.
Yeah, really what you're doing is you're setting each factor equal to 0. Just keep this in mind. 3 will never give us a 0. So that's off limits. It's not a solution. But 3 times, if you get a 0 in here, you know, and whatever, it doesn't matter what this is. As long as this is 0, we've got it. And then you use the same argument for the x minus 1. Now, I know you guys knew how to solve this, or at least I hope you did. So, x equals negative 3, or x equals 1. We need ordered pairs, though, because it said points. If it just said which values of the domain, you'd be done. How do we get the points, then? I'm going to work over here on my left. Oh, no, I can do it alone. What do we do? You do the arithmetic and the original function, the f, because we're talking about 2 points on the graph of f of x. So you use those points in that function. So you're finding f of negative 3 equals, and I'm talking, I'm going to underline that, using that, do some arithmetic. You should be able to do that arithmetic in your head. Like, you can write it out on paper, but I mean, without a calculator, you should be able to do f of 1 in your head for sure. So I look at it and I see negative 3 cubed is negative 27 is what I'm doing scratch work here. Negative 3 squared, so 27, and then minus, so 9, and 1 plus 3 is 4, minus 3 is 1. So, almost answered the question. Keep looking back. 2 points. Have a good weekend, young man. So the 2 points with slope 6. I'm going to just say the 2 points are 1, 1, negative 3, 9. And now, if I make a mistake, guys, you stop me. I hope I didn't. I've given all odds except for 26. Why did I think 26 would be a good one? Well, I'll write the answer down right away. 124. The following numbers is the slope of the line. Oh, okay, that's a pretty good one. That's not even calculus, too, for 26. I won't give you the answer there. You guys can figure that one out. And there's always the answer book up there too. Let me see here, 1. Oh, that's fast. Actually, these are fast, right? Because it's just like x squared, oh, 2x, the derivative, you know, things like that. 5. That's a nice one. 7. That's a sweet one. 11. You should actually get a good chunk of these, if not all of them, done in 16 minutes. Oh yeah. 26 isn't even calculus. 27. Okay, I'm going to pause the recording. Stop it.